one more step along here. We have to build a lot of T&D infrastructure. We know we don't like to have power lines in our backyards. We don't like to build a lot of new generation either. So I think what we really need to do is figure out a way to use the existing infrastructure in a much better way. So one of the things that we've been looking at is what we call a parallel market structure, using a concept of what we call flexible loads, which overlays on top of the existing market structure, but where the customers are incentivized to use only green electrons and to use them only when they're available at the point of use. Well, you'll say that, we didn't know that this could be done. Well, it actually can be done at a point of use or at a node like a city. It can be done fairly easily. I think Germany, for instance, has actually been trying to do that. But we also have the technology using the smart wires type of concepts, which allows us to actually, under contract, deliver green electrons if that's necessary. But anyway, I think the idea here is that, if we could figure out a way to have a parallel market structure, this might actually offer a lot of new opportunity. We call this FLEX, or flexible load electricity exchange. And the idea would be you have an electric vehicle that plugs into the grid, and it's the smart grid, of course, and the smart vehicle. So what it does is it knows something else, something that's very interesting. A typical vehicle is running for about 2 to 3 hours a day, and 21 hours a day it's stationary. If we could incent the car owner to plug the vehicle into the grid when it's stationary, you would have a load that would have to charge for about 3 hours, but would be connected to the grid for 21 hours. This would be the concept of a flexible load. So you could, at that point, think about allowing the vehicle to control its charging and to kind of demand that I will only charge when the green electrons are available from my variable wind resource and with the congestion and everything else factored in. So if you do something like that, you end up with something very interesting. So what this shows you here is the old chart that we had, where we had wind energy and the charging profile. And we now put the smart charging in here, where the car plugs in and looks for if the green energy is available. And if it is available, it accepts it. If it's not available, it looks at the weather forecast and sees whether it should wait or should take black electrons. And lo and behold, something very interesting happens. Something very interesting happens. You find that you do not have to have any new generation that is added. You do not need to have any new spinning reserve that is added. You do not need to build new transmission and distribution networks. So, all at once, the things that were creating the problem on a regular grid, start disappearing. And what we'll see on the next slide is that this has a tremendous amount of, saving that it results in. Here's the same chart with a fourth column added out here, which is 5% RPS with the flex charging capability. And what we did is we introduced this, keeping the carbon emission level the same as we had before, but you find that you reduce your cost by another $930 billion. So overall, what we see is that by moving to a smarter energy use model, by tweaking the market structure, you are able to use existing grid assets, and you're able to do it with a significant amount of saving in energy, in cost as well as in total dollars. So here, let's take a look again. So what we have here is our incremental electric capital cost, went down quite significantly. The fuel cost went down went up because we are now also taking the electric vehicles, in there. And what we find here is that the transportation sector cost is reduced. So under the flex cost, we are $2.1 trillion lower than business as usual and $2.99 trillion lower than for the RPS case. So, we get to the same place, but we get to it a lot cheaper. And I think therein lies an opportunity for us. We took the next step and said, okay, this gives us some some really big ideas in terms of how to get the cost reduction, can we have our cake and eat it too? Conventional wisdom suggests that, it's very difficult to meet IPCC goals. I mean, most of the discussions I've seen so far suggest that, IPCC goals are going to come with economic sacrifice. And that is something that may not be acceptable to most consumers. So here what we did is we kind of took the current electricity generation mix, okay, and just said, let's meet a 5% RPS. I think that's very doable without having to make significant investments on the grid. I mean, I was talking to some of the senior people at ISO who have the hardest requirements in terms of RPS, and they said, 5%, maybe 10% we can do without breaking a sweat. 20% we, are really sweating bullets, and 30% we really don't know how to do at all. Okay, so by kind of putting this at 5% level, I think it makes this very much doable. The second thing we said is let's set a goal for light-duty automotive fleet to be powered essentially from electrical energy, which is about 50% of current oil consumption. And the automotive fleet, to the extent possible, is powered using something like a parallel power market flex model. Okay, the aviation and heavy shipping needs are served by biofuels, which is about 20% of current oil consumption. The industrial organic feedstock continues to be supplied from petroleum, which is about 30% of the current oil consumption, which would significantly enhance security for the U.S. even in terms of petroleum uses. And then on top of that, we factored in a 7.5% improvement in efficiency of energy usage over 20 years, which by all counts is very much doable. What you end up with that is very interesting. You've got the yellow is the business as usual 2030, and the green is IPCC 2030. This is the primary energy that is generated. And what you see is that in the IPCC 2030 case, you still have a lot of coal, you still have a lot of nuclear, you still have a lot of gas, you have PV, you have wind. Oil has gone down as the primary energy source, and biomass has come up as the primary energy source. But you see a huge impact as far as emissions are concerned. So overall, the IPCC 2030 scenario allows us to meet energy security, economic growth, and sustainability at lower cost than business as usual. It makes sure that all the major constituents see some wins. Hopefully this becomes an easier sell politically. And it also kind of tries to transition from 2010 to IPCC 2030 using the existing infrastructure and to try to do it as to the extent possible using market actions and not just pure mandates.